In Germany, more robots are developed and used than anywhere else apart from Japan. The annual growth rate of the robotics sector lies between 5 and 10%. One of Europe's largest innovation centers for developing autonomous robots for industrial, services and domestic use is the Fraunhofer Institut for Autonomous Intelligent Systems in St. Augustin near Bonn. Over 10 years ago, a scientist of international experience recognized the enormous potential for autonomous robots at home and abroad. Professor Thomas Kristaller is director of the Fraunhofer AIS Institute and pursues very practical goals.
To develop robots which can function in place of human beings, in environments where humans can't or don't want to work. Underwater, for example, or on other planets, in places where catastrophes occur, or in sewers or areas in which humans need support.
The need for robots that can work independently of humans is particularly marked below ground. Macro Plus is the name of this multi-segment robot. Developed as part of a research project, it's designed for inspecting sewers. 2/3 of the 500,000 or so kilometers of Germany's public sewer system are inaccessible for humans. Apart from the huge amount of repair work needed on both urban and rural sewers, local authorities are legally required to inspect between 5 and 10% of their sewer networks every year. Even for a small town, that can easily amount to between 15 and 20 kilometers a year. Autonomous robots are ideal for this work. Conventional inspection vehicles are too complicated and expensive, according to the project partner company Renag.
The critical drawback is that conventional systems are cable-tethered and of only limited range because of the friction between the cable and the insides of the pipes. You can't change direction with this sort of equipment either, nor can it cope with changes in level. This means that every 100 or 150 meters, we have to bring the equipment to the surface again, and that makes the work very expensive and time-consuming.
A test in the sewers of the city of Siegburg. The Macro Plus sewer robot, which operates autonomously without cables, has two major advantages. Firstly, it can inspect lots of sewer sections, one after the other.
And secondly, it can branch off autonomously, not just move straight ahead in one direction. That means you don't have to keep lifting the robot out of one manhole and putting it back down another to inspect a branch sewer.
Multi-segment robots like Macro Plus will be able to inspect the 350,000 or so kilometers of German sewers which are not accessible to humans much more dependably and economically than the current equipment. And they can not only measure sewer pipe geometry, but also monitor chemical and physical parameters of the sewage. Macro Plus is still at the prototype stage in a Fraunhofer AIS research project which runs till mid-2005. The Fraunhofer researchers recognized early on that only an articulated device could successfully cope with the many differences in level to be found in sewers.
If the robot were too short, it would simply tip over when it tried to raise itself. And sometimes, when you're branching off into a side sewer, you get a change of level at the same time. Any robot that's going to maintain its stability, even under these circumstances, must have at least 6 segments.
The segments don't only guarantee stability, they also house all the inspection sensors, cameras and laser projectors for providing 3-dimensional measurements of cracks in the sewer and for accurately navigating sewer networks. Then there are ultrasound and infrared sensors for detecting obstacles and controlling the robot's own movements. It's the autonomous navigation in particular which makes Fraunhofer AIS robots suitable for a whole range of other tasks. Kurt 2, for example, which finds its way autonomously and serves as a versatile basic robot that can be equipped with various sensors and tools. The high-tech provider KTO was impressed enough to risk venturing into autonomous robotics. They're now producing the Fraunhofer AIS robot under license and selling it successfully around the world.
In USA, Japan, sehr viele europäische.
In the USA and Japan, and to many European research and university departments which use the system as a platform for their own research work. To engineering companies as well, who want to develop their own applications and can integrate their own equipment, actuators and sensors into the system.
Chord 2 is used, for example, for measurements or surveillance in buildings and open spaces. It measures with a precision 3D laser scanning process developed by Fraunhofer AIS, and at the same time calculates its inspection route so systematically that it selects only recording positions from which it can gain a complete scan of its target. Instead of wandering around aimlessly, it plans its route, saving time and energy. At the same time, Chord 2 is highly reliable.
Das System ist sehr einfach gehalten, hat klar.
The system is kept very simple, has clearly defined interfaces, is very robust and durable, and has the advantage that customers no longer have to concern themselves with the usual problems of an autonomous vehicle, but can concentrate on their own tasks or sensors.
For example, using the 3D scanner to map building geometries autonomously and therefore very cost-effectively, to inspect road or rail tunnels, to provide surveillance of security installations or museums, or create three-dimensional color-correct projections of historic sites and buildings. Chord 3D also corrects any inaccuracies caused by its own movements in individual scans by constant comparison with the geometry data of subsequent scans until it returns to its starting point. This closing the loop process enables the onboard computer to calculate a precise spatial geometry from all its scans together. Chord 3D achieves error-free measurements even in complex building structures with different levels and sloping surfaces.
Conventional systems lose their orientation because of the ramp, because it's no longer level. Through the 3D scanner, we always know exactly where we are in the X, Y or Z axis and the roll, pitch and yaw angles, which is why we call it the 6D slam.
Chord is capable of even more. Normally, robots measure their own position via the revolutions of their wheels. But if their speed makes them skid and the wheels spin, they lose their orientation. Thanks to its laser scanner, Chord 3D can also master one of the great challenges of robotics,
which is the SLAM problem, as it's known, which stands for simultaneous localization and mapping. It means the robot both locates its own position and produces a map at the same time with its laser scanner. In addition, this is the fastest indoor robot in the world. It moves through a location and always knows precisely where it is. This represents an enormous saving potential for the end user, who no longer needs to send in a group of surveying engineers who take days to measure up a particular environment. Instead, you send in the robot and it does it automatically.
With inventions like this, Professor Kristalla is not only fulfilling his own vision as a researcher, he's particularly pleased when solving a scientific problem has a marketable outcome, something that can never be foreseen at the start.
When people from outside spot exactly what it can be used for, when it's clear that it has applications and I can see what they are. Sometimes we ourselves simply don't know where something might be useful. But I believe that a well-designed technical system does have a primary application, which is what the designers first had in mind. With Chord, for example, we first thought of using it for sewer inspection. Then, after a lot of input from outside the Institute as well, we realized it could be used as a carrier platform for recording environmental data in general.
Innovations made in Germany. Despite these examples of world-leading robot technology, Germany no longer keeps the promise that's still often and fondly repeated, that of leading the field in technology and science.
My fear is that the basis of this made in Germany will no longer be there in future, the human resources. We train 40,000 engineers a year, but we're still 20,000 engineers short, according to the German Engineers Association, and that's every year. The only way of making up this major deficit in engineers is to get girls and young women interested in technology and engineering disciplines. It's too late to start doing that in the universities and colleges. We have to begin in schools.
A physics class at the Christophorus School in Königswinter. Carolina Dirks is in the 9th grade and only average in the science subjects. That's something she has in common with most girls her age. But Carolina and her classmates have very clear ideas about what a good physics lesson should be like.
Versuche auf jeden Fall.
Experiments, definitely, and a pupil-teacher dialogue, not just sitting and listening to what the teacher says, finding things out for yourself. Yes, carrying out experiments and doing things yourself.
The educational shortcomings in Germany revealed by the PISA study also affect subjects like maths and science. Physics teacher Claudia Huppertz knows that enthusiasm for technology and computer science is not aroused by traditional teaching methods.
If that's all that happens, it's too boring. The pupils switch off. They want to learn things in practice by doing experiments. Theory on its own is really bad.
To arouse the interest of pupils like Carolina Dirks in physics, computer science and technology early enough, and encourage that interest further, Fraunhofer AIS has developed a learning concept for youngsters from the 5th grade onwards, building imaginary robots. The concept is pitched at various learning levels to encourage the youngsters without making excessive demands on them. Those who like using their hands make things. Those who like computers write programs. Using age-appropriate programming language, the mini-robots are brought to life. Fun with technology at the press of a button.
You can try things out for yourself, instead of just being told about it. And it's fun to program something on your own.
Every year for the International Girls' Day, schools, companies and institutions, as here the Federal Ministry for Education and Research, invite girls to a hands-on encounter with technology. The robots are created in just 1 hour and are then given commands according to their particular skills via the tiny onboard computer. The moment of truth for their creator. Autonomous toy robots with no remote control. If it moves off, she's done everything right, experiencing success in practice, curiosity countering inhibitions.
Exactly. We see that most girls still choose what are thought of as typical women's jobs and ignore the whole field of technology, of which there's not much on offer in schools. And this is where you can really rouse the interest and enthusiasm of girls for technology, which hopefully will later be reflected in their careers. We're now training the teachers, and more schools are approaching us from all over the country to help organise project weeks, or in some schools, afternoon courses that run for 6 months. It's a question of more, wanting to know more, wanting to do more.
The Fraunhofer researchers have put together course curricula based on commercially available modular systems and their own robotic modules. Teachers are given easily understandable teaching materials to complement their training, for courses at all levels of intensity, with detailed guidelines and all sorts of robotic experiments designed for various age and ability groups.
And you can make use of these modules in a variety of subjects, in physics, computer science, programming, of course, but you can also create analogies to biology as well, by trying to replicate examples from nature in the robots.
Carolina Dirks and her fellow pupils might even find themselves carried away by these robots.
Sure, because if you do something like this at home, then it's mainly just on the computer, because there's no robot to apply it to. But there is here, and you see the result immediately, a real feeling of achievement.